Physics? How many of you? Only 2, 3 girls? No one? No one? Why? Okay, thank you. Thank you. God bless. Okay, why people usually don't like physics? Derivations. Because of derivations? Girls? You can speak at least something. Okay, today I am going to give a lecture on thermal properties of matter. Okay, it is a very interesting. Physics is a very interesting subject, and thermal properties of matter. Thermal properties is very interesting and important phenomena in physics. What are the things do you know about the thermal properties? Do you know something? Conduction, convection, radiation. Okay, first we are going to see about what's the difference between temperature and heat. What is temperature? What is heat? Temperature is the measure of coldness or hotness of a body. Heat is the form of energy, isn't it? Heat is the form of energy. Okay. Then, first, how will you measure temperature? There are so many instruments. So, best thing is thermometer. So, due to using thermometer, we can measure the value of temperature of any body or metal or anything else or a substance. Okay, so now we are going to pass on to the thermal expansion. Thermal expansion. Okay, what do you mean by thermal expansion? When heat is applied to any body or any substance, the material expands, isn't it? When the temperature is removed, the material contracts, isn't it? So expansion, contraction. So expansion when we are heating the body or heating any object. This will be done when we remove the heat or cool down the object. Okay. Can you say any example for this? Rail tracks. Do you know the best example is railway tracks or bridges? There is an what is actually there is a space between the track, isn't it? So during summertime this will expand, isn't it? So for that, if it is not given this means what will happen? It will expand, so it will bend, isn't it? So it will bend, so it may cause the damage or any accident, train accidents, isn't it? So this during summer it will expand. For that reason, that there is a gap is given between the railway tracks, isn't it? So another, I'll give you a I'll give you a small example problem. There are two metal strips are held together. So there is a different metals. The strip is made up of different metals. First one is A and second one is B, which are held together, and this is mounted on a rigid fixed table. Okay. So what will happen? So here the thermal expansion coefficient of A is greater than expansion coefficient of B. Okay, clear? Expansion coefficient of A is greater than expansion coefficient of B. So what will happen? This is immersed in a cold bath. What will happen? This setup is immersed in a cold bath. So if we immerse in a cold bath, we are removing the temperature, isn't it? So what will happen? It will contract. So what will happen? A material will bend, isn't it? A material will bend towards, A material will bend towards downwards, isn't it? So idu enna agum? Bend up, isn't it? Okay, suppose this is if you are immersed this in a hot bath, what will happen? A will expand more than B, isn't it? Because A's expansion coefficient is higher than B. Okay, is it clear? Are you able to understand, ma? Physics is not a toughest subject, what you are thinking. Okay, be smile at least in physics class. Start to love physics. Then you can learn easily. Derivation and all not at all easy because you are doing mathematics in a very good way, isn't it? You are doing mathematics, you know. So compared to mathematics, physics only having very simple derivations, isn't it? So if you understand the simple phenomenon in physics, you can start loving it because physics is the queen of science. Okay, so be happy with the physics, be happy with learning physics. Okay, so after this you can understand what I have said. Let's say, okay. Okay, then the another phenomenon is specific heat capacity. Okay, can you, any one of you explain specific heat capacity without definition? Without definition, can any one of you explain? What do you mean by specific heat capacity? Yes, please. Tendency of an object. Yes, very good. Right, sit down. Then, can you explain with real-time example? Can any one of you? Yes? Yes, ma? Boiling of water. Boiling of water. What is happening actually? Boiling of water. When we are applying heat, the water? Yes. Immediately it will start to evaporate? No, it will take some time. But very good, sit down. But up to a particular time, it will withstand, isn't it? Isn't it? So that is the capacity, that is the tendency of maintaining the same temperature. So by applying heat again and again, the water started to boil, and it after crossing the boiling point, it started to evaporate, isn't it? So specific heat capacity is nothing but when we are applying heat to the substance, the temperature of any substance. Suppose we are taking 1 kg of substance. Suppose we are taking 1 kg of substance. The substance 1 degree Celsius, to rise 1 degree Celsius of this substance to how much amount of heat we are giving, that is called specific heat capacity of that substance, isn't it? So suppose already the boiling the water has the temperature of 60 degrees Celsius, isn't it? 60 degrees Celsius. I want to make this as 61 degrees Celsius. Okay, 1 degree Celsius. So I am giving how much amount of heat I am giving to raise the temperature from 60 to 61 degrees Celsius is called specific heat capacity. Okay, so this is denoted by capital S, which is equal to 1 by m Q by delta T. Okay, what is meant by Q? What is Q? Specific heat required to raise the temperature. So 1 degree Celsius to raise 1 degree Celsius, how much amount of heat required is Q. Okay, then delta T is change in temperature. Okay, change in temperature. So it will come 61 minus 60 means 1 degree Celsius. Okay, so what is m? Mass of the substance. Okay, so we can take an, if we have taken 1 kg of substance means the m is 1 kg. Okay, suppose if you are taking the amount of substance in molar, in moles. So this will change as molar specific heat capacity. So molar specific heat capacity. So the formula for molar specific heat capacity 1 by mu into Q by delta T, where mu is the moles, amount of substance we can take in moles. Okay.
Good evening, students. For your kind information, there is no extracurricular purchase. There is no extracurricular purchase.
Okay, the another interesting phenomenon is latent heat. Latent heat. Latent heat is nothing but amount of heat required to change the state of any substance, isn't it? Change the state. Suppose if you want to change the water to ice, or ice to water, or water to steam, water vapor. So that is called latent heat. There are two types. One is latent heat of fusion. Another one is latent heat of vaporization. So what will happen later at the latent heat of fusion? Yeah, the temperature required to melt the object, isn't it? Melt the ice. This one? Okay. At what point this will happen? For water, 100 degrees Celsius. Very good, very good. Girls, you can speak. You can speak at least. You are forbidden to speak. No, no. Then speak. Okay. LV. What is LV? Latent heat of vaporization. Yeah. Okay. Okay. Then another thing is heat transfer. How heat is transferred from one object to another object. How? Yeah, conduction, convection and radiation. Conduction, convection and radiation. What is actually happening in conduction? Vibration of molecules. Suppose, sit down, thank you. Suppose molecules are situated like this. Okay, if you are sitting closely, means in a solid matter, molecules are closely packed, isn't it? So if you are giving heat, okay, by heating this side, what will happen? If I am giving heat to you, I am touching you with any hot substance, what will you do? What will you do? What will you do? You will jump, isn't it? You will jump, isn't it? Sit down, sit down. So what actually happens? She will jump. She will touch her. Then she also jumps. Then like this happen in conductions. So molecule get the heat energy. It gets vibrated from its equilibrium position, and then and the energy is shifted to this. Only this in solid matter. Object will move, molecules will move. Molecules will move? No. Only the energy thermal energy only transfer to another molecule. They will oscillate or vibrate from its equilibrium position. It will jump and sit in their own places. Okay. Then the energy only it will transfer. The heat energy only will transfer to the another end. Okay. This is called conduction. That what do you mean by convection?
Through a medium.
Through a?
Medium.
What medium?
Liquid or gas.
Liquid or gas. So it needs a medium.
The particles are most rarely spaced than in conduction.
Okay. How the energy gets moved?
Through vibration.
through vibration, or here only in conduction only. Sit down, very good. Here only the energy is moving. Yes, ma, yes. Yes, the particle itself moving, isn't it? Sit down, very good. Convection means the particle is moving. So, do you know any example for that? Convection?
Steam.
Steam? Then?
Flame.
Flame? Any others? Fragrance, yes. We'll get the heat. Very good. Sit down. What is radiation? I thought you have not get this point correctly. Convection. We are boiling water in a pan. What will happen?
Correct.
Don't go for the phase change, okay? We are just boiling. What will happen? You put a vessel, you put a big vessel, okay? There is pour some water, full of water. So what will happen? You are giving, slowly applying heat to the vessel. So what will happen?
Heat from the vessel to water.
Yes. If you put your hands inside, what will you feel?
Heat.
You are applying slowly, ma. You are applying slowly. Heat is applying in a slow way. What will happen? Temperature rise. Temperature. It's okay, ma'am. Temperature rise. How it will rise? Okay, you are applying heat. It will rise. How the energy? Suppose. Sit down. I'll tell you. Suppose you consider this as a vessel. Okay, you are giving flame here. You are applying flame here. So what will happen? This molecules, this water molecules, what will happen? It gains the thermal energy and it moves upwards, isn't it? What will happen? It moves upwards, na? But in solid, in conduction, only energy is transferred. Thermal energy alone will get transferred. But in convection, this particle which carries the thermal energy will go upwards. And this one will come down. Then this will go up. So once up to the thermal equilibrium is reached, this will go up and down. So every molecule is which carries energy and moving upwards, isn't it? So this is convection. Then what do you mean by radiation?
Without any heat. The movement of transfer of heat from a body to another body without any medium.
Without any medium, just radiation. Throw any example? Sit down, ma. Sunlight.
When you have a campfire, the heat is.
Yes. So radiation, transfer of heat from a body without any medium, isn't it? So do you know about a black body?
Yes.
Yes, black body is a. What do you mean by black body? It's a when you say it is a perfect black body.
So it's 100%.
Yes, when you are giving 100 Kelvin temperature, it will take every 100 Kelvin into it. It will absorb the complete radiations of at all frequencies. It will not neglect anything. It will completely absorb all the things we are applying, the heat energy, which is called perfect black body. Okay. So do you know about the black holes and all? Do you have any idea? Can anyone of you tell me a few words about black holes? Yes, please. Give my option. Yes, please.
Yeah. Light.
Yes. Yes. If you go near the black hole, what will happen? Oh, it will absorb as. Very good. Sit down. Okay, there are few laws depends on the black body radiation. So Bion's displacement law. So Wien's displacements law. What is that? Lambda m into t is equal to lambda m into t is equal to constant. Lambda m is nothing but wavelength of the radiation. Okay, wavelength of the radiation, T is the temperature. So which is equal to constant. Okay. Then another form law is Stephen-Boltzmann law. Which is the amount of heat radiated is directly proportional to the area of cross section and T bar. Stephen-Boltzmann law. Okay. Yeah, little more things when it's not. Okay. Okay, A T bar 4. Okay. This is H is the amount of radiation. Amount of radiation is directly proportional to the A into area of the surface. Okay, surface area, and T bar 4. We can change the proportionality as sigma A T bar 4. Here sigma is the Stephen-Boltzmann constant, isn't it? Okay, then. So problem some. Can we go? Okay. Okay, in a problem, I have read the problem. The specific heat of water is 4200 joule per kilogram per Kelvin, and the latent heat of ice is 3.4 into 10 to the power joule per kilogram. If 100 gram of ice at 0 degrees Celsius is placed in 200 gram of water at 25 degrees Celsius, the amount of ice that will melt as the temperature of water reaches 0 degrees Celsius is close to, we are going to find out. Okay. So first I'll write the problem. You can also write it. Okay. The specific heat of water, I'm sure writing shortly. The specific heat of water is 4200 joule per kilogram per Kelvin. Okay. And latent heat of ice. (3.4 into 10 to the power 5 joule per kilogram). Okay, first understand the problem clearly. Okay, the specific heat of water is given as at 4200. That's the constant value for joule per kilogram per Kelvin, and latent heat of ice is also given 3.4 into 10 to the power 5 joule per kilogram. So what is given means, if 100 gram of ice at 0 degrees Celsius is kept in a vessel of 200 gram water at 25 degrees Celsius. Okay, now what will happen? What will happen? Ice is kept inside the 200 gram of water, which are at the water temperature is 25 degrees Celsius. So what will happen? First understand temperature. What will happen? Ice, think in a simple way and answer, ma. Ice will Melt. Ice will started to melt, isn't it? So in question they are asking the amount of ice that will melt as the temperature of water reaches 0 degrees Celsius. How much amount of ice is going to melt in this temperature when the temperature is at 0 degrees Celsius? Okay, got the point? We are going to calculate how much amount of ice is going to melt. Okay. So you take mass of the ice. How much the mass of the ice? 100 gram. Yes. Then mass of the temperature of the ice? 0 degrees Celsius. Then mass of water? 200 gram. Okay. Then 25 degree Celsius. Okay. So we are changing this into kilogram because the other values are given in kilogram. So we are changing this into kilogram. What will come? 100 gram is equal to 0.1 kg. This is equal to 0.2 kg. Okay. So heat. So what will happen? Sorry, I deleted the diagram. What will happen actually? The water loses the heat temperature. So heat lost by water is equal to what? Heat gained by the ice. Yes, first we will calculate this, then equate the two equations. Okay. So heat lost by this one. W into delta Q. So what will have substitute these values? 0.2 into specific heat of water 4200 into this temperature 25 degrees Celsius. So what will come? Nearly 21,000 joule will come. Okay. Yes, Q, that is Q, isn't it? MSQ. Yes, sorry, T, okay, sorry. Okay. Then heat, next heat gained by ice, isn't it? It is equal to MISIT. Yes, ma. How? Enema? No, not necessary. But in the problems, we don't want to change because we are only calculating, measuring the temperature means that is possible. Otherwise, we don't want to change the temperature into Kelvin. Okay. Yes, sir. Heat capacity. Definition, sir. So the amount of heat required to raise its temperature by 1 degree Celsius. 1 kilogram of substance to 1 kilogram, 1 degree. Yes, sir.
1 degree means unit, kilogram per degree Celsius.
Yes, sir.
1 Kelvin means Kelvin. As we told, Kelvin is correct answer.
Okay.
So we are definition into 1 degree Celsius.
Yes.
1 Kelvin is correct.
Yes, okay. Then we so we can calculate this value. How much amount of ice is melting, we don't know, isn't it? So we can keep this as mx. Then 4,200. So that latent heat of ice is given, you know. So 3 point. What is the value, ma? 3.10 to the power 5. Okay. So we can equate these two equations. So mx is equal to 21,000 joule by 3.4 into 10 to the power 5. We will get nearly 61.7 gram. Okay, it will come in kilogram. We will change it into kg. Okay.
Thanks, my students. Looking at us, yeah.
Yes.
Louder.
Stephen Boltzmann law. Sit down, please. Stephen Boltzmann law, the amount of heat radiated, that is H, is directly proportional to the fourth power of the absolute temperature. Okay. Please ask.
Heat transfer for
Yes.
you have written the formula as ms T, right?
Hmm.
But it is delta T or normal just T? ms T or ms delta T?
No delta T, only T. T. Temperature here not changing, you
But
know.
T refers to final initial temperature, right?
Yes.
But we have written a last
Yes.
heat last, then it will be delta T, right?
Q by delta
Delta
T. I have wrote delta T.
No.
No.
You didn't write because
Yes, delta T only. But I forgot to write delta. Okay.
No.
Okay.
What is relationship between our topic and black body?
What is the
Relationship between our topic and black body system. Explain about black body.
black body?
Yes.
Black body is nothing but it's a complete absorber of all radiation, all frequency radiations. Is there anything you want to know?
Whether that is ideal or real.
Real black bodies are there, you know. You are asking about black holes.
Yes.
Black holes.
But black body is
It's a real one. Okay, it's a real one. Yes.
What is the difference between specific capacity and heat capacity?
Sir, heat capacity is a general one. Specific heat capacity is a particular, if water has some specific heat capacity, it's water only has that value, sir. If you are giving temperature to rise, water temperature to 1 Kelvin, it is called a specific heat capacity of water. Specific heat capacity, every metals or solid or everything have some specific values. That is specific heat capacity. So, heat capacity is a general term. How much amount of heat the material or the solution or liquid can withstand.
There is no mass in heat capacity.
Yes, sir. Specific. Yes, miss.
Right? Told the reach displacement of lambda mt equal to constant. What's the value of constant? You cannot say it's a constant. Let's get number. No?
Yes, sir.
What's the number?
Sir, I forgot it. Sir.
And if lost by the water equal to gained by the solid in the last sum.
Yes, sir.
It comes under which principle?
Calorimetry, sir.
Newton's law.
Newton's law of cooling.
Do you have any number for the expansion of coefficient of any metals? First, stop here. Expansion coefficient of metal. A,
Yes,
B,
sir.
and
Yes, sir.
Can
Yes.
you give some example for that?
Example.
A to the X.
So solids are having. Sorry, you are asking about thermal expansion.
Coefficient of two metals. Bimetallic state. The beginning class you don't know.
Yes, sir.
The expansion coefficient of metal A is greater than metal B.
Yes.
Any number examples like that.
Examples, but the number I didn't mug up, sir.
The decision of day-to-day life. Home.
Yes, sir. That is kettle. Kettle, you know, sir. Water kettle or that
Water business.
water kettle. Otherwise, that cooker, rice cooker, sir.
Bimetallicity.
Yes, sir. There's an when the heat is equilibrium state, it will that switch is there. No, it will come down automatically like
Iron
that.
box will exist.
Iron boxes.
So, just let me give some data. Based on that, find the specific heat capacity.
Yes.
Take initial temperature as 15 degrees Celsius, final temperature as 75, heat supply 500 joule, and mass 1 kg. Find the specific heat capacity.
So tell me once again. Yes, sir.
Initial temperature 50 degrees Celsius.
50, sir. 50 degrees Celsius.
Final temperature 75,
75.
heat supply 500 joule,
Hmm.
and mass 1 kg. Find the specific heat capacity.
Okay, specific heat capacity 1 by m into Q bar delta T. So 1 kg. Formula is right. So you want the exact value?
Yeah, that's fine. And also write this.
Twenty joule per kilogram per Kelvin. Joule per kilogram per Kelvin. So I haven't changed the
You have to convert this. Can you convert the step relation in Kelvin?
Kelvin. Yes. Subtract, then after that we have to convert. So delta T we can take it as a Kelvin, degree Celsius is same only, sir. Thank you. Just a confusion.
From the body sublimation.
Sublimation without the solid material is converted into vapor without change into liquid directly.
Okay, thank you.